Hello, everyone. This is actually first time presenting topic of analog astronauts to the community, which is known like it's not a specific conference within the community of analog astronauts, but this is a place where people actually knows what are analog space missions. Because most of the times I am presenting analog space habitats, nobody knows what is this. So yeah, but if they know, they think, oh, it's just a game, it's like a LARP, as you mentioned before, but it's changing. But it's changing for good. Okay, a little bit about me. The most important thing, I'm an analog astronaut. So this thing is the most important. And the second one is that I'm a co-principal investigator of RAF Analog Space Project with Mikołaj, who is sitting here. And Mikołaj then will be talking about our projects that we are doing in Poland. So for those are three things that I will be mentioning throughout the whole presentation. Just a little bit about habitats, astronauts, and then like a whole mission and things that you can get out of it. Who don't know anything about analog space missions here? Oh my God, everyone knows. Perfect. So I don't have to make this introduction because everybody knows what are analog space missions. So it's like a simulation environment for space. Maybe Moon, maybe Mars, maybe something else. But I want to make a really quick timeline just to see how the idea of analog space mission evolved throughout the years. So first of all, those are the things that I had in my head that I put it here. Maybe you can disagree, maybe you will have some more important points to add to this timeline. But the first point I mentioned was Ben Franklin submarine. This is quite interesting point because the whole Picard family is pretty crazy. This is a Swiss family. All of them are basically scientists, oceanographers, and they also did the stratospheric balloons experiments. And that was the moment when Jacques Picard, sorry for my French, Jacques Picard went with Don Welsh for the trip in the Ben Franklin submarine. And that was the project held with US Navy and NASA. And basically what they done, they were researching isolation. So that was the beginnings of idea, maybe we should do something with that. Maybe we should see how people will behave in isolation. Then I mentioned the Philippe Zimbardo prison experiment. We can argue about that. Is it a good one or it wasn't not? It's a controversial one. But what they did, they studied simulation and immersion, which is like a key point for analog space mission. You have to go deep into the immersion to actually feel like you are on a different planet, that you are somewhere else, to make it sense. Because when you are thinking, oh, this is just a trip, I'll be back in a few days, okay, it's nice, nothing makes sense. Then first, attempts to create the real analog habitats. So I mentioned BIOS 3, that was the Russian habitat. They mostly focus on life loop support systems. They did quite well, we can call it like that. Then was the Biosphere 2, and that was a huge project. Huge project created by a bunch of hippies. I really recommend to watch the documentary about the biosphere. I was shocked when I saw how actually started this project. But it was also mostly focusing on helping people to understand planet Earth. Not only to think about space, but also to better understand planet Earth. As well, controversial project, but still the important one. And at the Biosphere, each year is Analog Astronaut Conference. So this is a place where people gather to talk about analog space missions, so it have to be on the timeline. Then I mentioned Decays for Mars, which I think is quite important because it, in my opinion, it a little bit changed the perspective and the way that we are thinking about planning the mission. I love doing something with nothing because it's the best way. If you can invent some big experiments, some stuff that can work, but without the huge amount of money. And that's why I really like it, because NASA and other agencies are proposing plans for the future exploration with thousands, billions of money. But if we can make it cheaper, why not? Then NASA DRADS project, analog simulations on deserts in different places, which has also quite interesting outcomes. And then 2000, FMARS and MDRS, and of course the Mars Society, the beginnings of actual real analog habitats that we know nowadays and what we try to replicate if we are building habitats or doing analog space mission. Then the really big one, Mars 500. That was the 520-day mission, a long one. What is interesting about it, it was simulating the flight, which took 120 days, and then the crew reunion with the rest of the crew in the habitat, and then the project was going again for the rest of the time. Quite interesting one. And at the end I put it the human exploration of Mars design reference architecture, because in my opinion it's quite important document that was created created by NASA about how mission design should look like, what we are supposed to do. So if you are designing mission, I recommend to read it. It's quite interesting. Okay, so now I want to mention some habitats so you can see how habitats can differ from each other. Because what we think about habitat, we think about maybe some dome, maybe some like can shape building, but they can be really, really different and have a quite different purpose. So, of course, high seas on Hawaii, NEMO, so underground habitat, and Concordia Station, which can serve as well as analog habitat. It's isolated, you do the research there, you are in a team, you have procedures. It's like an analog habitat. Then, Polish accent, Lunares, of course, in Piła. 3D printed habitat created by NASA, really interesting projects. I couldn't find any pictures of that can actually show how the habitat looks now, because it was created a while ago. But they do like a really weird pictures when you can see like everything, but it's in circle, so you actually cannot see how it looks like. So it's just a graphic that they done before building it. And of course, Austrian Space Forum. Next, Astroland. This is quite interesting project because they mostly do research, and the analog space missions that are underground inside the cave, there are like few days or sometimes just for a few hours or for a day, because they mostly do training there. But it's also quite an interesting place. Hera, really old habitat, but classic. And the habitat from Southern Hemisphere, Habitat Marte in Brazil, also a little bit different from other habitats. And I have to mention mine habitat, the RAF project that we done. So when I mentioned if you want to do something with nothing, yes, you can. You can build an analog space mission and habitat with not that much resources. So our project was located in Bytom. Mikołaj will say more about this. And yeah, we can go to the next points. Who is an analog astronaut? Easy question. person who goes into the simulation and lives in a habitat and do the tasks that they're supposed to do. They do the research, they test technologies, procedures, and teamwork in isolation. What else? What are the roles in analog space missions? They can differ from different missions. Sometimes there is use for having a little bit different roles, but those are the standard ones. As a commander, deputy commander, mission engineer, science officer, medical officer, communication officer. Those are the classic old standard roles. And the next point about EVAs. What is the purpose? Mostly to see how people will behave outside the habitat. Because there are a lot of habitats that don't do EVAs at all. You have to have equipment, you have to get prepared, you have to have standard procedures. It takes time, it is hard. When I had my first EVA, I was a little bit shocked how hard it actually is. Because what is a big deal? You just go out for an hour. When I go out from my house for an hour, for example, or two, I don't make a huge deal about it, but actually in analog space missions, it is a huge deal. It simulates the condition outside. So that's why the location of habitat is also quite important, to have something that will actually simulate, for example, Mars or Moon. And of course, you can test life support systems and some accidents, risk, communication delays. There are a lot of things that you can get out of the EVA procedures. So now I'm gonna use a little bit of data and talk about things that are, for me, quite important. So who is flying to space? Mostly US, Russia. I think that was quite obvious, but this is how gender statistics look like. Yeah, no comments for that. Actually, I thought it was better. I thought it was much, much better, especially in last couple of years. But we can say we improved, and then something happened. I don't know, 2024. Yeah, so there's just 12% of female astronauts. Why? No idea. And those are the data that Leszek from Lunares give me. So I have to give him a credit for this data that he allowed me to share. So what is the gender ratio during analog space missions and inside the analog habitats? We can say 50-50, something like that, which is much, much better than in normal space flights. And those data are similar to different habitats. Can you agree that in your habitat it's also 50-50? More or less. Yeah, but it's better. It's not 12% of female, I assume. And of course, habitat is in Europe, so most of people are from Europe, but still there is a bigger diversity than in space flights. And a little bit about the profession. So as we can see, every profession is quite important for analog space mission. You can be whoever you want. It doesn't matter. If you want to go on a mission, you have a purpose, you are passionate about it, and you actually want to do the mission, you can be architect, you can do some humanistic studies or medicine or something else. And age ratio. So mostly people between 20 to 29 years old. And then is a huge gap. So this is what I think we are not talking enough about diversity and actual benefits that can come from the diversity in space missions. For example, diversity in leadership. there were studies conducted even in analog habitats about female leaders. So they were studying the female commanders, how the crew will behave when the women are commanding. So what was funny, the crews were more efficient, the teamwork was improved, and basically you can see the difference, the actual difference. And if you have a diverse crew, you can think outside the box. You exchange perspectives, you exchange the views, you exchange your background. So it is making you think more outside the box. So the teams are more innovational driven. When we look at the research that is like a high level research, we see how important is collaboration between institutes, between countries, between people. And those are the things that are created and have a huge impact, where there is a lot of diversity, where is collaboration between the teams. And of course, there are much more things that I can add here, like, for example, improved research impact. That was research done about the research papers, actually. Someone did the research about research papers and diversity in writing research papers. That was quite interesting. Increased innovation, as I mentioned, cognitive focus, and of course, positive innovation effect. That was the research done in Canadian firms about the gender and education diversity. So then I have to ask you a question. How long it takes to go to Mars, to fly to Mars?
6 months.
Six? We estimate 6 months? Okay, so after what time the first bad symptoms of being in space appear? Guess. Like a really bad ones. Some symptoms, some situations that can affect your health. After what time of being in space? It's less than a month in most cases. So if we are gonna travel 6 months and our health will decrease, who will we be if we land on Mars? I think that most of the people will be disabled on Mars, actually, if they landed. So that's why I want to mention a little bit about the human health risks of flying to space. For example, what will happen with your muscles and your bones? So just 2 weeks and you lose 20% of your muscles. Mostly legs, back, 2 weeks. Bone density, you lose like from 1 to 2% per month. And of course, there is a bigger risk of fractures. And it's just a month. Then fluid shifts, issues with dizziness, fainting, reduced blood volume. It doesn't sound nice. SANS, for example. So, like, did you know that 30%, there is a 30% sight loss after coming back to Earth from ISS? Not good at all. Problems with immune system. When you are affected by the cosmic rays, your possibility of infection increase. You can have more viruses. And of course, isolation stuff. So stress, sleep issues, higher risk of conflicts in small teams. And trust me, I don't know the team which wasn't in a conflict throughout the mission, even the small one. And cognitive problems. So this is why we should study and have more missions with people with disabilities. Because I know there were projects. There were some analog space missions that were including people with disabilities. But still, we are mostly researching on health people. What we do like a training, physical training. We check if they have muscles, if they are able to lift something, if they are capable of doing basically something. We are looking for like a really, really super people. On some case, okay, you cannot find like a Superman or Superwoman, but still, we are looking for some specific things in people, you know? But if those people, even really good on Earth, go to Mars, they will have issues with walking. Maybe they wouldn't see anything. They will have issues basically with everything. So why? Why we are not focusing on studies people, on people who actually face these issues here on Earth, to know how to improve in the future when we actually gonna land on Mars. So, for example, we should study hearing loss on people who had hearing loss. This is what can actually happen on in a space flight. You can lose your hearing. Partial vision, as I mentioned SANS before. How we can improve the architecture, the habitat, if we won't be able to see it properly, you know. Some prosthetics, maybe people who have leg disability, so they cannot move. So everything with limited mobility that can appear. Some neurodiversity things, because, you know, cognitive and psychology of the person will change throughout the whole flight, and on the mission they can appear different types of things. So we also should research that. Diabetes, which is also interesting, because diabetes can actually help to improve the medical procedures and testing on the bodies, like, for example, conducting some blood tests or things like that. And, of course, testing pacemakers and implants to make sure that they are resistant to radiation. So anyone can become an analog astronaut. And I have a few minutes left, so I just like go through it really, really quickly. So what are the benefits of analog space missions? There are a lot of stuff. Testing, risk reduction, crew training, scientific research, cost efficiency, what was mentioned previously, international collaboration, and a lot of stuff. What is done in analog space habitats? We do biological, ecological research, a lot of them. We do human psychology and health, a lot of the research about it. Technology and engineering, life support systems, rovers, robotic arms, things like that. And of course, energy systems. This is also quite important. Social interactions and team dynamics. So communication, improving communication, group cohesion, and cultural cognitive diversity. And of course, we do environmental and geological research. So EVAs mostly. And do you know how many there are innovations that come from space sector? Like, yeah, there are a lot. There are a lot. I just mentioned few of them that we are using here. And I was wondering why there is so many things that are inventing for the space sector and then are used here on Earth. And then I figured out that when we are on Earth, we have unlimited resources. So basically, you want something, you're just thinking, okay, this type of thing that I need is in US, so I would just order it, no problem. Oh, this element that I need is from China. Okay, I can order it. They will come maybe after 3 months, but I will order it. Is it possible? But when we think about space, we have to think that we don't have nothing. So what can we do with nothing? Then we started thinking more and more and more. So that's why we are improving. So that's why we have better technologies. Yes. And this is everything from my side. You can scan the QR code if you are bored, because there are the resources and everything that I use, so like thousands of pages if you want to read. So, But yeah. Do you have questions?
Only one question. You choose.
Oh my god. I saw you first, so
I think at the same
sorry.
time, so I don't know.
So it's one question and a comment? It's
Yeah.
Okay. So the comment is, for example, I have a friend, she has long COVID, but she would have loved to apply to the analog astronaut mission, but she doesn't know how to do it. But since I saw what you just said, like having people who are like feeling weak, maybe it would still make sense for her to apply, right? Okay, I tell her, that's perfect.
If you don't apply, you don't know how far you would get.
Yes.
Okay, I will tell her. And then the next question, like my question is, with all the new habitats popping up, for example, there's this one in Brazil,
Yeah.
Stellaris. What do you think about those new initiatives?
I think they are good, actually, because we need to break through the vision of analog space mission that is just a game, it's just an experience. And we have to also know that there are different types of habitats and they have different visions for what they do. So there are habitats where actually everyone can go. So there are more or less no restrictions, some basic stuff. And there are habitats where you have to apply. You have to go through really hard training, and the whole application form is quite long and it's time-consuming. There are habitats, for example, where you need to be for example, U.S. citizen to go. So those are the restrictions. But there are also habitat like Habitat Marte, which is focusing mostly on outreach, education, and improving the science communication, which is as well really, really good because it's needed. We need good science communicators nowadays. But there are different habitats. You just have to look for what you need or where you can apply, because they are completely different from one another. As I shown, those are different vibes, different procedures. Everyone have different idea for their own mission. So you have to look and see what is the most suitable for you.
So you work on the diversity in this case as well?
I think we should be open much, much more on that we are right now. Because I know in total 3 or 4 para-analog missions. Maybe there were more, but I know 4, something like that. So is it enough when we compare it to the amount of the missions that are conducted each year in all habitats in the world? I don't know if we will go up to 1%, I don't think so.